Well, we are in our fourth session in our review of the book of Genesis. And if you recognize that in this fourth session, we're still in chapter 1 and taking a few verses at a time, let me put your mind at ease. We're going very slowly through the 6 days of creation for some very fundamental reasons. As a person who studied the Bible for more than 4 decades, I have to tell you that I was startled to realize how fundamental the concept of creation is to this whole issue of the final judgment. We've just done a comprehensive study on hell and heaven and all of that, death and dying. And I was surprised to realize how fundamental your concepts of the creation are if you have no other knowledge of the ruler of the universe. He holds everyone accountable on the basis of we need to understand the creation. It's not just a casual doctrine. So we're going through the 6 days very casually, and because they each embrace some discoveries scientifically that we as just aware people need to be sensitive to. So we're going very, very slowly. To give you a feeling for the entire book, we'll be going through the book of Genesis in about 24 sessions in total. So once we get through chapter 1, the pace obviously will pick up a bit. We won't be dissecting it to that level of detail. But before we get into the material, you probably have noticed my beads. Anybody notice my beads? Okay. You're probably wondering, what on earth? Yeah, I occasionally wear these when I speak to make the host nervous, you know. I wonder what is Chuck up to this time. Well, these are some beads that came about a very strange way. I spilled a bunch of black and white beads on the floor, and I picked them up randomly and threaded them on a string. And the strangest thing happened. After I put them all together, I noticed that it spells out Morse code. Did it as I, dotted as N, in, then there's dot T, 4 dots, H, in the beginning, God created the heaven and the earth. Now, it happened to be Genesis 1:1 in Morse code. All by absolute random chance. How many of you have just believed the story I've just told you? Why are you laughing? Why are you laughing? If you believe that this happened by accident, I've got some property I'd like to show you. No. You know, it's interesting. You haven't done the math, but you know, just from your gut, that that's impossible for 247 beads to arrive in exactly that order that would represent that kind of intelligence. In the beginning, God created the heaven and the earth. I assume that verse rings familiar to you as the opening of the Bible. Well, that's really what we're going to talk about. I used to call these the beads of Waitangi, and I wove a tale of the Waitangi people in New Zealand, because I was doing it on the birthday of New Zealand, and I tied it in, and I thought it was clever, but it ended up, you always have to allow for some pastor in the weeds who doesn't read the whole article and misses the last line, you know. And so anyway, it created so I backed off that approach. I used the way I'm using here. But the real question is, what's the chance of this being by chance? Could this have occurred by random chance? Well, let's analyze that a little bit. There are 347 beads here, and they're either black or white. So there's an alphabet of 2, right? So the chance of any particular sequence, a specific sequence emerging, happens to be 2 raised to the 347th power. Or that's roughly equivalent to 10 with 104 zeros after it. Now that's a big number. It's probably a bigger number than any of us in this room, me included, have any capacity to imagine. It's a very large number. You see, any number with more than 10 with 50 zeros after it is defined in physics as absurd. As you start getting into these probabilities that are very, very rare, there is a point in mathematics where you need to have a cutoff. And in science, they've decided that 10 to the 50th is, I forget whose law it is defined as absurd. By the time you get that large, you really are out there. It's highly unlikely. So unlikely, they're saying it doesn't happen. So now, this is just a simple string of 347 elements. You know, you wouldn't allow me to try to sell your kids that this happened by accident, but you send them to school where they teach them that we happened from an accident. You and I came from a rock. And let's just take one molecule. We're going to talk about molecules a little bit tonight, so I'll use that as my excuse to get into this here. In your blood, you have a thing called hemoglobin, right? Hemoglobin happens to consist of 574 elements, not from an alphabet of 2, but an alphabet of 20. Okay, so that complicates it quite a bit. In fact, these are the 20, and I won't go through that here, but there are 20 different amino acids, and it takes 36 of one kind, 68 of another, and so forth. But they have to also be in a specific order. If you don't get the specific order, it's called hemoglobinopathy. It's usually fatal. The formula for such linear arrangements, and I won't take you through the factorials, but it comes out to 10 with 650 zeros after it. So if this is 104 zeros after it, and your hemoglobin 650, what's the likelihood that hemoglobin happens by accident? It's really, really absurd, okay? And yet, if only one of those sequences is hemoglobin, there's a few places there can be some tolerance, but very little. And otherwise you have what they call hemoglobinopathy. It turns out to be basically a blood disease that usually is fatal. So much for that. Now, the impossibility of chance, you need to understand some of these numbers. If you assume the world has been around for 18 billion years, like many scientists do, that's only 10 to the 18th seconds. If you take the entire history of the universe as conceived by the astronomers, call it 16, 18 billion, whatever, that's only about 10 to the 18th seconds in the history of the universe. You see, 10 to the 18th is a big number. We're talking 10 to the 650, you've got to be kidding. There are only 10 to the 66th atoms in our entire galaxy by common estimates of the scientists. And if you take subatomic particles, there's only 10 to the 80th. You see, and we're talking here just 10 to the 104. Get serious, guys. And as I indicated, 10 to the 50 is absurd. And the specificity then of the hemoglobin is far beyond any rational comprehension of it being ascribed to chance. Let me give you another way to rationalize it. Having the hemoglobin happen by accident, most of you are familiar with the Idaho lottery. I understand the odds there are about 1 in 80 million to win. What's your chances of winning it every day for 90 days in a row? You see? Not likely, okay? So we have the elements of language. There's a thing called semantics. What do the symbols mean? These symbols, just black and white beads. The symbols that are used in hemoglobin, each one has a meaning. It defines amino acid. Remember Paul Revere's ride, 1 if by land, 2 if by sea, and all that? That's one of the simplest binary codes you can find. It's a 1-bit message. 1 bit's a carrier bit. It's either, that just proves the guy didn't fall off the ladder getting into the Old North Church. There's the 1 bit, 1 if by land, 2 if by sea. You remember all that? Do you realize that if the British at that time had the most powerful supercomputers, they couldn't have cracked that code? Because its meaning comes about only because of prior arrangement. You couldn't crack that in a typical cryptograph. So anyway, again, did that code occur randomly? No, by careful planning. People agreed that if it's 1, it's going to be this, 2, if it's going to be that way, and so forth. So anyway, these are coding structures. There are very simple alphabets. Most of us have seen those. There are codes that are designed to be error detecting. When you use your computer, you have 8-bit bytes. You only need 7. The reason you have 8 bits, the 1 bit's a parity code. It's an error. It detects if there's an error. If you use 11 bits, you can make it error correcting. You can do 3 parity checks overlapping so that when you get the parity error, it'll tell you which position the error is, and since it's binary, you can reverse it and you've corrected it. So it's possible. There are computers that have been built, the ENFSQ 27, that you can actually go and pull cards out while it's running, and it continues running. Our air defense computers are built of that kind. So there are error detecting codes, there are error correcting codes. In other words, codes themselves can get incredibly sophisticated. There's probably not one engineer in 1,000 that knows how to design an error detecting code, certainly not an error correcting code unless that's his area of specialization. There's also adaptive coding, codes that will modify themselves depending on the occasion. That's a whole other level of sophistication. Now, we talked here about a simple alphabet, a simple binary string. and that's 10 to the 104th. The hemoglobin, that was 574 elements by 20. The DNA code is a shocker, not just because it's complicated. The DNA code is an error-correcting, not error-correcting 3 out of 4 binary code. It is an incredibly sophisticated code. Scientists are still just beginning to discover some of its features. And we'll talk more about that when we get to day 6. We're in day 4. DNA is 3 out of 4, error-correcting, it's a code that's self-replicating, error-free, and it's error-correcting from cosmic rays and other such things. It doesn't have 247, it's got 3 billion elements defining the manufacture and the arrangement of hundreds of thousands of machines. In that code, it defines the machine and arranges it for its manufacture. It consists of unique assemblies selected from over 200 proteins, not an alphabet of 2, but an alphabet of 200, each involving 3,000 atoms in three-dimensional configurations. And they're all defined from an original alphabet of 20. So what's the probability of that happening by chance? No way. No way. The DNA molecule has put the final nails in Darwin's coffin as far as any rational concept of chance is concerned. And we won't go through the code here. We'll do that when we get to but we are going to see that one reason I get into this here is in day 3, which is we're undertaking, we are going to we've encountered all kinds of interesting things so far, the fabric of space and all that. But now we're going to encounter this strange thing called life. And so we had an introduction to the Torah the first time we met, talked about authorship, the book of beginnings, the nature of time itself. We talked about the age of the earth and such things. And then in day 1, we talked about the possibility, the conjecture, that there may have been a gap between verses 1 and 2. We talked about the origin of Satan, because Satan has fallen by the time we get to the chapter 3 of Genesis. Where did he fall? When were the angels created? The angels were created before the earth, because they sing, Job tells us, when the earth was created. So they're very early. Well, when did Satan fall? No one knows. It's a mystery, but we talked about that. We also ran into light, the first quote of God, let the light be, and we talked about the bizarre discoveries they're making about light itself. And then the last time we met, we talked about the fabric of space. That space is, the vacuum of space has all kinds of surprising physical properties, not the least of which a cubic centimeter of empty space cooled to absolute zero has more energy in it than 100 million suns. And that sounds bizarre. The whole concept of zero point energy is a shocking concept coming out of physics. We talked about the nature of space, we talked about the Big Bang models and that sort of thing. But now we get to the third day, and we're going to encounter the land and the seas and life and vegetation. So we'll talk a little bit about the origin of life, and we'll talk about thermodynamics a little bit, molecular chemistry, and we'll introduce you, if you haven't ever been exposed to it, what scientists call the anthropic principle. So we started this session originally with Genesis chapter 1, verse 1. In the beginning, God created the heaven and the earth. And if you understand that verse and accept it, everything else in the Bible will fall into place. But you start there. And the earth was without form and void. Darkness was upon the face of the deep. And the Spirit of God brooded or moved upon the face of the waters. And God said, let there be light. And there was light. And God saw the light, that it was good. And God divided the light from the darkness. Interesting phrase. I always thought darkness was the absence of light. No, we're talking about darkness that's tangible, black holes, what have you. There's a difference. We move on. God called the light day, and the darkness he called night. And the evening and the morning were day 1. And so not the first day. The second, third, and fourth, fifth day are relative days. Day 1 was an ordinal number. It was the first of days. It was day 1. The next day was not day 2. It was the second day. Big difference. But anyway, we talked about that last time. God said, let there be a firmament, a rakia, in the midst of the waters, and let it divide the waters from the waters. And God made the firmament, divided the waters which were under the firmament from the waters which were above the firmament, and it was so. And he called the firmament heaven, and the evening and the morning were the second day. And we explored that last time. So here we are for this session. And God said, let the waters under heaven be gathered together in one place, and let dry land appear. And it was so. And God called the dry land earth. And the gathering together of the waters he called he seas. And God saw that it was good. And God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit after his kind, whose seed is in itself upon the earth. And it was so. And the earth brought forth grass, and herb yielding seed after his kind, and the tree yielding fruit, whose seed was in itself after his kind. And God saw that it was good. And the evening and the morning were the third day. So that's our task before us. We have the land, the seas, and vegetation, or life itself, beginning here. And exciting stuff. We need to talk briefly, we have in the past, we'll touch on it as we go through. There are two basic laws in the universe that we need to understand, because they certainly help us. One is, they're both the laws of thermodynamics. There's actually three, but we'll just deal with two of them. The first law, the conservation of matter and energy. Matter and energy can be exchanged one with another. That's what the E equals mc squared thing of Einstein is. It tells you how much energy you get for how much mass. But the point is, matter and energy cannot be created nor destroyed. In all the operations we see, matter and energy cannot come from nowhere. It has to come from somewhere. And it can't be created or destroyed. Another way of putting that is you can't win. So it's in the scripture too. I won't go through all that here. It'll be in your notes. Second law of entropy, and that's probably, for you and I, probably the more important one, the entropy law. All processes involve a loss. In thermodynamic terms, there's always heat flows from the hotter body to the colder body. But in doing so, some of it is lost to the ambient. And when the ambient is all uniform, no more work can be done. It's as if the whole universe has been wound up like a clock and it's winding down. And so we call the ambient entropy in thermodynamic terms. In an information sense, it's randomness. It's interesting that the laws of entropy apply not just to thermodynamics, but they apply throughout all fields of science except one. There's only one field of science in which the scientists close their eyes and pretend that the entropy laws aren't there. And that's the field of biology. And they don't recognize that you can't create information. Information has to be added externally. And we'll talk a little bit about that as we go here. But conservation of matter and energy is in the scripture. Genesis 2, verses 2 and 3. On the seventh day, God ended his work. It's from that point on that most scientists that understand the scripture believe the laws were frozen, they're firm. From that point on, nothing is, up till then, God is creating. But from that point on, he makes things, shapes things, but everything that was needed is in place. Hebrews 4:3-4 says the works were finished from the foundation of the world. His works were finished at that point in the physical sense. All things that are therein, you preserve them all. God keeps them that way. The second law, Paul refers to in Romans 8 as the bondage of decay. And you notice the scripture in Psalm 103, it says, they shall perish and grow old as a garment, meaning the heavens. The earth shall grow old like a garment, in Isaiah 51:6. Heaven and earth shall pass away. These things that we think of as eternal, physically are not. They'll pass away. They have an end point. Maybe billions of years, whatever, but there is an end point. But I have an example that I thought I would share with you. I brought with me an experiment that we'll perform here. This is a jar of peanut butter. I stopped by the market on the way here, and I thought it would be instructive because what we have here is an open thermodynamic system. There's some material inside that you can see because it's through the glass, and energy can enter and leave this container. In fact, light can too. That's incidental to our purpose. Now, if we understand the teachings of modern, quote, unquote, biology, life can be created from matter plus energy. Well, we have here some matter. In fact, I've got a handicap because the matter in here happens to be organic matter. It's not inert, it's organic, okay. Also, we've added energy to this. Now, what I want to do, if I believe what they teach us in school, not very often maybe, but occasionally, if I have matter plus energy, there may be new life inside. So when I get home from the market, of course, I take off the top, and it's sealed. It's sealed to keep information out. I'll explain that in a minute. And if I open this up very carefully, there's no new life inside. Aren't you glad? Yeah, exactly. Now, you say, Chuck, what are you getting at? Obviously, you're relieved when you take the top off and there's no new life inside. The only way there would be new life inside is if a spore or a contaminant got in there. It takes some information to be added to it. And now, I used to use baby food, but the women got upset with me when I did it. An empirical test. They would teach us that life is when you have matter plus energy. That equation in your children's textbooks is incorrect. That's not true. You see, that's not a correct equation. Life comes when you have matter plus energy plus a third aspect called information. It can be in the form of a germ. It can be in the form of a spore. It can be in the form of some additional external contaminant that might cause something that then could multiply and what have you. All cells in the entire universe come from a previous cell. Nowhere do we see any of them made. They derive by being split. And a very, very profound thing. There's something about life that is not in any of the chemical equations. And that's what's beginning to be introduced here in this session. The food industry that you and I depend on conducts over 1 billion experiments each year. They've been doing that for over 100 years. And they rely on the fact that evolution is not just unlikely, it's impossible. It's impossible if they take care to make sure that no information gets in the container. So the theory of evolution is not only illogical, it's disprovable every time you go to the store, every time you buy a product, and every time you're relieved to discover it's not got new life inside. You're relieved, you're grateful. So I want you to remember that next time you go to the store, okay? If we make an entropy profile of the universe, I've got randomness, entropy, maximum entropy at the bottom of this chart, minimum going top, or putting entropy being like chaos and minimum entry is order. And obviously and Erev and Boker came to mean later evening and morning for some reasons we explained in the earlier sessions. Erev is really where you begin to, you have disorder, you can't, lack of perception. And that's what happens in evening as the shadows extend, you can't see as clearly. Boker means orderly, it's discernible, and that later became meaning morning. So that's why we have this peculiar description, evening and morning were the first day. It later meant evening and morning, but we have Erev and Boker being steps from going from disorder towards a step towards order, if you will. And that was day one. And then Erev and Boker made day two. And now we're in Erev Boker in day three. Now it's interesting, we're encountering the seas and water. It's kind of interesting if you go through the history of hydrology, and I won't go into detail here, but obviously in the 1500s, Galileo was famous for his telescope. He also was one of the first to make a crude thermometer. And Torricelli, his secretary, made a barometer. We talked about that last time. And that's where he began to sense such things as atmospheric pressure and altitude studies. Robert Boyle in 1660 developed what we call now Boyle's law. He developed the relationship between volume and pressure of a gas. A few years later, Robert Hooke developed an anemometer which could measure wind. In 1700, Perrault and Adama Perriot perceived and described the water cycle on the Earth. I want you to notice that year, it was 1700. 1714, Gabriel Daniel Fahrenheit measured the boiling and freezing points of water. That's where we give our temperature scale, the Fahrenheit scale comes from that. In 1802, John Baptiste Lamarck started classifying clouds. In 1806, Beaufort developed the wind scale. And so about 1812, Tchaikovsky's overture of 1812 time period, if I can use that, it was the first weather map. So that's a rough flavor of hydrology. It's interesting, though, 1700, they began to realize that there is a water cycle. Well, Solomon tells you all that in the text. In Ecclesiastes 1:6-5, he asks a very interesting question. The wind goeth toward the south and turneth about unto the north. It whirleth about continually, and the wind returneth again unto its circuits. So the wind follows circuits. That's an interesting insight, Solomon. But then he has, all the rivers run into the sea, yet the sea is not full. Well, that's an interesting thing. Have you ever think about that? All the rivers go into the sea, but the sea doesn't get full. It stays there. Why? Because unto the place whence the rivers come, thither they return again. And he elaborates that in the book of Job, talks about this, Job 36. He maketh small the drops of water, they pour down rain according to the vapor thereof, which clouds do drop and distill upon man abundantly. Put those together, you have the water cycle. It took them till 1700 to codify. But it's astonishing to discover how the Bible, incidental to its purpose, anticipates scientific discoveries. The water cycle we've just gone through. The jet stream is described in Ecclesiastes 1. The whole concept of evaporation we've just talked about. It also talked about in Amos 9:6. The source of river water. Fresh water springs in the sea, Job talks about in Job 38. Did you know that there's fresh water springs in the ocean? Many people don't know that. But one that fascinates me is in Psalm 8 and in Isaiah 43, it speaks of pathways in the sea. Now, most of us read those passages and treat them as poetry and don't stumble over them. But there's a guy that was fascinated by that. There's a guy by the name of Matthew Fontaine Maury. And he was fascinated with this phrase that there's paths in the seas in both Psalm 8 and Isaiah 43. So he was born in 1806 in Virginia. And in 1825, he resolved to chase this down. And the way he did it was he joined the Navy as a midshipman. And in 1842, he was put in charge of the depot of charts and instruments. And he started organizing the collection information of all the ships that were sailing. And he collected this data, and then he published maps in 1848 of all the main wind fields of the earth. And he is recognized around the world as the father of oceanography. And when you march at the Naval Academy from Bancroft Hall, which is the dormitories, down Stribling Walk to the academic group, the center building of the academic group is, Maury Hall. And Matthew Fontaine Maury. So as a Naval Academy guy, I had to work that in. But it's interesting because he was a Bible-reading guy, found something in the Bible that puzzled him, and it altered his life. That became his career. And he founded the area of oceanography. There are many stories like this. It's interesting that there is a science quiz, and I'm not going to give it to you. God is. If you read the book of Job, you know that Job goes through a real ordeal, and the real ordeal wasn't just the loss of his wealth and the loss of his family and the loss of his health. The real ordeal was the friends he dragged along. If you got friends like that, you don't need enemies. And most of the book of Job is this dialogue as these guys talk about why is Job sitting on this ash heap so forlorn. Well, finally, near the end of the book, the last 4 chapters of the book are the fun part of the book. Because God finally says enough's enough, and he steps in. And he starts asking them questions. And there are 77 questions in the final 4 chapters of the book of Job. And science's mandate, by the way, in the scripture comes from Genesis 1, verse 28, where Adam is told to subdue the earth. And science is supposed to pursue and find truth. And it used to. There used to be scientists that were God-fearing, Bible-literate people. Modern scientists are totally illiterate of the Bible, have no grasp of what it's about, and furthermore, are committed not to truth, but to developing an explanation that denies God. It has to be totally mechanistic. And if you try to do more than that, you get fired. The landscape's littered with careers that have cracked up on that one. It should have been, science should have been the great testimony to the majesty and the glory of God. Instead, it's become a device for ignoring and rejecting him and preying on the uninformed. And so, as we go through these questions, many of them people can't even answer today. And it's really a shame that the founding fathers of science, guys like Newton, Boyle, Pascal, all these guys were God-fearing. But the modern ones are the humanists. And Christians, by their indifference, have allowed them to take over. They've acquiesced to the satanic takeover of our primary priesthood in our culture. But let's take a look at some of the things that God asked. We're just going to look through Job 38 quickly. The Lord answered Job out of the whirlwind. Interesting place to call from. It says, "Who is this that darkeneth counsel by words without knowledge? Gird up now thy loins like a man, for I will demand of thee, and answer thou me." Now, I like that. Stand up and be counted. Stand up like a man. And where wast thou when I laid the foundations of the earth? Declare if thou hast understanding. See, all these conjectures, Big Bang, whatever, are futile, because God was the only guy there. Let's listen to what he says. And the Big Bang's a little bizarre anyway. You know, first there was nothing and then it exploded. That's their explanation of it all. But anyway, according to the book of Genesis, some 35 times in just the first chapter of Genesis, and also in these 4 chapters of Job, God created each thing with its own specific attributes and the powers of reproducing after its own kind. And they're digitally defined. One reason we have these definitions we now understand is that they're defined by digital codes in the molecules, not analog, digital codes. And each one has its own object and a purpose. And God holds us accountable, not to know the particle physics, but to understand that he did, and it's a testimony to him. He goes on, who laid the measures thereof, if thou knowest? Who hath stretched the line upon it, whereupon the foundations thereof are fastened? Who laid the cornerstone thereof? When the morning stars sang together and all the sons of God shouted for joy. The angels were there and shouted for joy at the creation. So they were created, but earlier. Interesting. And we're going to turn now to the most prominent features of the planet, the seas. The seas cover 3/4 of the surface. And who shut up the sea with doors when it brake forth, as if it had issued out of the womb? And when I made the cloud the garment thereof, and the thick darkness a swaddling band for it, and brake up for it in my decreed place, and set bars and doors, and said, hitherto shalt thou come, but no further, and here shall thy proud waves be stayed. In other words, God set the boundaries. He shut it up and firmed it up. He's going to do some things about that when we get to chapter 6, 7, and 8 with the flood of Noah, and we'll come to all that there at that time. But God continues, hast thou commanded the morning since thy days, or caused the day spring to know his place, that it might take hold of the ends of the earth, and that the wicked might be shaken out of it? It has turned as clay to the seal, and they stand as a garment. And from the wicked their light is withholden, and the high arm shall be broken. It's interesting, in verse 12 there, the precession of the earth causes the sun to shine in a different place each morning according to the seasons. And if it was any different, we wouldn't have life on this earth. I'll come to that in a little bit. God continues, hast thou entered into the springs of the sea? Hast thou walked in the search of the depth? Have the gates of death been opened unto thee? Hast thou seen the doors of the shadow of death? Hast thou perceived the breadth of the earth? Declare if thou knowest all. Where is the way where light dwelleth? And as for darkness, where is the place thereof? It's the springs of the sea, by the way, back there, the language implies fresh water. And many people don't realize there's fresh water in the oceans. There's no way that someone in Palestine would know that. Their only exposure is the Mediterranean. That doesn't really, they wouldn't have exposure to that kind of actual empiricism unless they traveled a lot further. And of course, death is still a mystery to us. Science has not made a dent in understanding death, and according to the scriptures, they never will. And so, have you to perceive the breadth of the earth? This is the one we have some answers to, thanks to satellites. We can measure the earth today. It's a little, that's one we've got cornered probably. He goes on, that thou shouldest take it to the bound thereof, that thou shouldest know the paths to the house thereof. Knowest thou it because thou wast then born, or because the number of thy days is great? Hast thou entered into the treasures of the snow? What on earth is that about? We'll look at that briefly. And hast thou seen the treasures of the hail, which I have reserved against the time of trouble, against the day of battle and war? Boy. Now, verse 23 may be a reference to the eschatological use of hail, as we see. We saw it in Joshua chapter 10, the long day of Joshua, and all through a lot of passages speak of the end times, speak of hailstones. It's kind of interesting to realize how God works. What was the punishment for blasphemy? Stoning. What happens to the earth because of its blasphemy? 97-pound hailstones pound the earth in the book of Revelation. So God is consistent in the idioms that he uses. But there's some physics yet to be discovered, I think, in the treasures of the snow. We'll look at that a little bit. God continues here, by what way is the light parted, which scattereth the east wind upon the earth? How is light diffracted? There's a whole issue here. Why are the stars red shifted is another way of asking the same question. And who hath divided a watercourse for the overflowing of waters, or a way for the lightning of thunder, or caused it to rain upon the earth where no man is, on the wilderness where there is no man, to satisfy the desolate and waste ground, and to cause the bud of the tender herb to spring forth? Hath the rain a father, or who hath begotten the drops of dew, out of whose womb came the ice, and the hoary frost of heaven? Who hath gendered it? The waters are hid as with a stone, and the face of the deep is frozen. You know, there's a lot of interesting questions hidden in all of these things. Why is there beauty in the desert? Why is there? And why is there beauty in the depths of the sea? We go down with cameras so deep in the ocean that it's black, it's dark. We turn the lights on and it's colorful. No one can see it, there's no light there. To please God. Why are flowers beautiful? They're not functional, bees are colorblind. Think about that. And now ice is going to disobey some physical laws in a very peculiar way, and we'll explore that here in a little bit. Then he goes on, he says, he's challenging Job, canst thou bind the sweet influences of the Pleiades or loose the bands of Orion? Now most of you that have a little astronomy background know if you look up at the night sky, there's a group of seven, well actually there's more, but there's 7 conspicuous stars called the Pleiades, the 7 sisters, right? How many knew that? Okay. There's also a constellation, Orion. We sometimes call them the Irishmen. We're just kidding. How many know about the constellation of Orion? You're familiar with it? I think most of you realize that those apparent pictures in the sky are just apparent pictures because the stars that make them up, some can be very close and some can be millions and millions of miles away. They just happen to look like a group. They're not really a group. Do you follow me? You understand what I'm saying? There are 2 constellations in the sky that are gravitationally linked. The constellation of Pleiades, those 7 stars, have a gravitational involvement with each other. And the constellation of Orion is the other constellation that is gravitationally close enough that they are a group. They are the only 2 constellations in the night sky that are gravitationally linked. Now, there are not many astronomers that know that. A friend of mine explained it to me. But it startled me because how did Job know, or the writer of this know? Where God challenges, canst thou bind the sweet influences of the Pleiades or loose the bands? Can you loose the bands of Orion? No, they're gravitationally linked. The others aren't. Whoever composed this had an insight into astronomy that's beyond the knowledge of most astronomers today who are not aware of that. But the next one is also, canst thou bring forth the Mazzaroth? That's the Hebrew term for what we would call the zodiac. Can you bring forth the zodiac in a season or guide Arcturus with his sons? We'll talk about this next time because that's when we're going to get into all this stuff at the next day. Knowest thou the ordinance of heaven? Canst thou set the dominion thereof in the earth? Canst thou lift up thy voice to the clouds, that the abundance of waters may cover thee? Canst thou send lightnings where they may go and say to thee, here we are? Who hath put wisdom in the inward parts, or who hath given understanding of the heart? This whole issue of lightning falls under the story of chaos theory. And why lightning goes a certain way is one of the most advanced theories of mathematics. And here, interesting, it's echoed here. Who can number the clouds in his wisdom? Who can stay the bottles of heaven when the dust groweth into hardness and the clouds cleave fast together? Wilt thou hunt the prey for the lion? He goes on now and he'll talk about, for the rest of this chapter and the next one, about his care of the animals, and he goes through a lot of that, and he finally talks about dinosaurs at the end of it. The illusions that we have seen in this include, as I mentioned, the rotation of the earth is in there, verses 12 through 15, the springs and pathways of the sea, the breadth of the earth, the travel of light, the dividing of light, the source of rain and ice, the universal nature of the physical laws, and electrical communications. All of these are in those verses we've just skimmed through. Now, hydrological cycle, we talked about that, the evaporation, circulation, precipitation, that's in Job 28. How do the clouds stay aloft, Job asks? The air and the wind have weight. See, water weighs more than air, so how can it be supported? And then we have the space-time mass of the universe. He stretches out the north over empty space. He hangs the earth on nothing, he says in Job 26. The morning stars sing at the foundation of the earth. There's a lot about the creation tucked away in the poetry of the scripture too. But I want to focus now on the water molecule. We talked about that before, but I want to ask you the question, why does ice float? It shouldn't. Everything we know, almost everything we know, when it gets colder, it contracts. When it gets warm, it expands. That's why bridges, have the little slot, because when the bridge gets big, they have to have room to you've seen that. So we talked last about the model of the atom. We have a hydrogen, an atom that has a nucleus and an electron going around it. This is obviously not to scale. Why? Because the atom is about 10 to the minus 8 centimeters. The nucleus is 10 to the minus 13th. In other words, the difference between the nucleus and the radius of that thing is 100,000 units. So you see, if you make the nucleus the size of a pinhead, the electron is spinning about a football field away. You understand what I'm saying? If you take the atom in cubical terms, oops, I pushed the wrong buttons here. 10 to the fifth power in 3 dimensions, 10 to the 5th times 10 to the 5th times 10 to the 5th, is 10 to the 15th. So if I say, is this podium solid, I'm lying to you. It's electrical, it feels like it's solid, it's electrical simulation. There's more empty space than there's matter here by a factor of 10 to the 15th. The ratio of matter to space in this podium is about the same as 1 second is to 16 billion years. So you and I are living in an electrical simulation, strangely enough. But H2O, I think most of us recognize as 2 hydrogen atoms that have combined with oxygen. We're familiar with that. Carbon atom is a little more complicated, got double rings and so forth. And it forms the basic molecule of biological things. We talked last time about plasma and how these are the 4 states of matter, remember? Plasma, gas, liquid, solid, so forth, as the entropy gets pulled out of it. First, plasma is first, we just have these atoms in ions, and we have the electrons floating around. As we pull energy out of that and put order in, it gets to be a gas where these things start to become H2O molecules, but they're still fluid in a gaseous form. As we pull energy out of that, it becomes a liquid, and it gets more definitive, and when they finally bring enough energy out, it bonds itself into a crystal, becoming a solid. So we've gone from plasma to gas to liquid to solid, the 4 states of matter. Many people are only familiar with 3. The plasma occupied us in the previous session. Okay, well, if that's the case, I want to go on a little further now. If we do a thermal profile of water, as we talked last time, the plasma cools down, it becomes steam, and the steam finally cools down where it gets water, and the water cools down, it becomes ice. I want to zero in on this peculiar place where water becomes ice. Because the atom has been designed to make an exception to the rules of physics or physical chemistry. If we look at the volume and the temperature, as water cools down, it gets as cold as 4 degrees before anything else happens. It then expands drastically when it gets to 0 degrees centigrade before starting to contract again. Because it expands, its volume is larger per pound than it was before, which means ice floats. The molecule of the water molecule has a peculiar structure such to cause that to happen. You've got a very peculiar angular relationship built in that molecule so that when it freezes, it causes it to occupy a larger space in order to take the crystalline structure it has. And so that's why, as it gets this crystalline structure, you have all these different, you've all seen these snowflakes. They say that no 2 snowflakes are alike. I don't know how they can say that because they have to look at them all to be sure of that. But anyway, but we've all seen pictures of this. They all build around it's all replications, if you will, of this basic molecular unit. The point that I'm getting at, though, is if ice did not do that, life would be impossible on the planet Earth. Because rivers would freeze from the bottom up, fish would not, and on it goes. You would not have life. It turns out if you follow that through, you would not have life. God has amended the mechanics of that particular molecule to make life possible on the Earth. And that's going to show up in some very strange way. We talked about the death of Darwinism already, the advances in microbiology. We talked about the digital code. Darwin cannot explain the origin of life because he cannot explain the origin of information. The issue is not when did life begin. The question is where did the information come from? Information doesn't come from randomness. They're opposites to each other. And so there's a concept of irreducible complexity that Michael Behe has introduced that we want to understand. I have here a mousetrap. It consists of 5 parts. A basic platform on which there's a spring that loads a hammer. There's a holding bar that will hold that hammer back and hook itself on the catch, and you have a mousetrap. It has 5 parts. You can't get rid of any one of the parts and still have a mousetrap. It's what we call irreducible complexity. It's very simple, you say, but it has a minimum number of components without which it will not function. If I have only 4 of the 5 parts, I don't catch 4/5 as many mice. I catch 0. You follow me? There's a very profound fundamental insight here. It's that because that's true, this couldn't happen by chance, because it's non-functional at all its intermediate stages. It's until someone puts it together that way that has any function at all. There's a concept of irreducible. Let me give you an example in nature. You take a bacteria that has a little tail that drives it through the fluid. We want to take and examine this particular bacteria. The flagellum is this tail, and we're going to examine carefully where it's connected to the bacteria through an electron microscope. When we examine that carefully, we discover something astonishing. What connects it there is an electric motor with 40 parts. Any one of those 40 parts missing, it doesn't work. And it's got C rings and L rings and P rings, and I won't go through the whole thing. You quickly get the glimpse that this is a complicated piece of engineering. And here's the functional description of it, how it operates from the, it's an electric motor. Most of us, okay, so we have a map of physical reality we're going to pursue during this study. The human body is where we're going to end up. There's organs. The organs are made up of tissues. Tissues are made up of cells. Cells are basically made up of molecular robots. The robots are built from an atomic structure, the atomic structure from subatomic particles. And the subatomic particles have no locality. You cut them in half, they no longer are local. They're everywhere in the universe. Very bizarre discovery about non-locality of these subatomic. We talked about the last 3 things last time. This time we're going to talk briefly about cells and these molecular robots, just briefly. We will talk about tissues and organs in the human body when we get to day 6. We're only on day 3. But I want to lay some of this groundwork. One of the fictions that they use in school is the thing called a simple cell. We now know there is no such thing as a simple cell. That's a fiction that Darwin, in good conscience, probably adopted because he didn't know better. But today we know that's a naive statement. Michael Denton, in 1986, the Australian evolutionist, published a key book on this. He said, although the tiniest bacterial cells are incredibly small, each is in effect a veritable micro-miniaturized factory containing thousands of exquisitely designed pieces of intricate molecular machinery made up of 100 billion atoms, far more complicated than any machine built by man and absolutely without parallel in the non-living world. The simple cell, its unparalleled complexity, and it has an adaptive design. It has a central memory bank, central library where the information is held. It's filled with assembly plants and processing units. It has repacking and shipping centers. It has robot machines in the form of protein molecules that typically consist of about 3,000 atoms in 3-dimensional configurations. And there are hundreds of thousands of different types, specific types of these things. It also has an elaborate communication system with quality control procedures and repair mechanisms. It even can muster armies to attack invaders. So if you were going to make a model of the simplest cell, and we're going to make this model 1,000 million times larger than real, each atom we're going to say will be about the size of a tennis ball. We're going to make this big model. We're going to take, each atom will be represented by a tennis ball. We'll need 100 million atoms, 10 to the 13th. If we could pull together 1 per minute, it would take us 19 million years to assemble those tennis balls. The model in doing this would be over 10 miles in diameter, so you get the feeling what we're up against. The actual cell has a plasma membrane which has gateways for exchanges. It has signal receptors so it can get message traffic. There's a cytoplasm, which is a fancy word for one we don't know what it's made of. We have a nucleus, which is the information center, and that's where the master library is that everybody else will consult. Inside there is the nucleus, which is the automated factories, and that's where they do the product manufacturing. Then you've got these power plants, which provide the energy for the city to work. It's like a miniature city. And then you have the Golgi apparatus, which processes, packages, handles the shipping, and prepares for export. And then you have all these little vesicles which storage, transport, do trash disposal. They all have functions. This is a veritable city. Now, We have robot machines, hundreds of thousands of different types, artificial languages and decoding systems. We have memory banks for information storage. We have elegant control systems for regulating the automated assembly of the components. We have prefab and modular construction going on. And we have error, fail-safe, and proofreading devices for quality control. We have devices that go around and check to make sure it's right, and if it's not, it rejects it. Now, let me give you an example. I was at Ford Motor Company. I was an executive at Ford for 6 years. And one of the proud facilities of the Ford Motor Company in Dearborn is the River Rouge plant. It's very famous for lots of reasons. It happens to be the largest integrated manufacturing plant in the world. You have raw limestone, iron ore, and coal go in one end. In the plant, they make their own steel, they make their own paint, their own glass. They have automated part of the plant that makes the engines. Anyway, the raw material goes in one end, and new cars drive out the other end. And it builds these, it's also interesting to watch because they're building a mix, have different kinds of cars and different colors all on the same line. It's incredibly, very complicated plant. I think there's 97 miles of railroad in the plant. Huge facility. It's worth the tour if you're there. In fact, it's broken down into about 2 or 3 tours. You always want to see the assembly plant. You have a choice of either seeing the automated engine plant or the steel mill. The engine plant always takes you, but there's nothing to see. There's nobody there. It's all automated. It's an automated engine plant. But the reason I mention this, once you've seen that, I can make the statement that the simplest cell is more complicated than the River Rouge plant at the Ford Motor Company. And that sort of gets it across if you have any feeling for that sort of thing. The cell is unequaled in any factory on the planet Earth. After having said all that, it's capable of replicating its entire structure in a matter of a few hours. When the time comes, there's a choreography that takes place where it will duplicate itself in a matter of hours. There's no way, if you had 1 million employees, you could do that to the Rouge plant. All cells derive from other cells. That's very important. Any fishermen out here? I want you to take this challenge. I want you to imagine that you had 2 strands of monofilament fishing lines 125 miles long, and you're going to roll all this up and store it inside of a basketball. Okay? But here's the rub. You want to set this up so you can unzip it, copy it, and restore it on spools at 3 times the speed of an airplane propeller without tangling. Set aside all the coding and all the intellectualese about the DNA. Just let's talk about the physics of it. If we do this in the scale of a basketball at 125 miles a line, can you imagine trying to figure out a way to scroll up all that line into that basketball, knowing that very, very frequently, several times a day at least, they're going to want to come and copy the information that's on that fishing line. So you've got to unravel it, copy it, put it all back again, and do this very quickly. Astonishing. Do you know what library is read more than any other library on in the planet Earth? You. Your DNA in each of your cells is read over and over every time they multiply. All kinds. Whenever it needs to make some manufacturing equipment, it goes to the master library, makes an RNA copy. We'll go through all that in another session. But incredible stuff. But here's the other thing. There's a mitosis mystery. If the initial cell divides into you look through a microscope in school, you see a little cell, it divides into 2. Mitosis takes place, you now have 2 identical ones, right? Then the 2 become 4. 4 become 8. They're all identical. But then you keep watching it, and something very strange happens. As it starts to get bigger and bigger, a dark line starts to form. And you realize that ultimately becomes the backbone. And you discover these cells are doing something strange. They're no longer splitting as duplicates. They start specifying. Some become cortical tissue. Some become muscular tissue. They start becoming all these different tissues which become different organs. Well, there's a very profound problem here. I want you to see if you can relate to this. Let's imagine everyone in this room could play every instrument in an orchestra. You had that skill. Let's assume you had every instrument that was necessary in the orchestra. And let's assume I gave you a copy. Gave you each a copy of the entire orchestration of a symphony. Would we have a symphony? Why not? There's something missing, isn't there? All of you have all the information you need in that copy I gave you. You have access to the instruments you need. You'll discover somebody has to conduct. Somebody has to choreograph the thing, or put it another way. It says, you're going to be first violin. You're going to be percussion. You're going to be whatever, whatever, whatever. Somebody, it may be arbitrary, it may be all equal skilled. Somebody still has to say, you're going to do this. There has to be a conductor. The fact that there's a single cell with all the information you can imagine in the cell doesn't explain life. Some of the experts have convinced me that God is personally involved in every cell division. Can you handle that? Because they all require an external input. You see, you can have all the information, you can have all the material you need, you still don't have a symphony. Somebody has to orchestrate. If you two are the first two cells in the first 8, somebody finally says, okay, you guys are going to be this, and you guys, someone's got to conduct it. Interesting. So anyway, who decides the specialization? In the computer industry, we call that conflict resolution logic. Okay, let's talk about one thing, and then we'll get on with it here. The anatomy of a leaf. You can look at any good encyclopedia and find a diagram of the leaf. You'll discover it is complicated. It's got special cells that guard things, that allow certain things to pass through and other things not, and so forth. But it is this chloroplast, this green thing in the middle, that we're going to talk a little bit about. You notice we're at the perfect time of year here. You notice the leaves starting to turn, the brilliant colors, because the pigments that normally assist the plant in photosynthesis, they're different. They capture different wavelengths of light, and the pigments are visible then as the leaf starts to die. You begin to see the pigments that you normally wouldn't see because they're masked by the chlorophyll itself, which is green. That's why they look green, because they absorb all the other colors, primarily red. Photosynthesis means to build with light. Basically, your leaves on these trees are sugar factories producing millions of new glucose molecules every second. Millions of molecules per second, each leaf. Most plants produce more glucose than they use, and so they store it as starch and other carbohydrates in the roots and the stems and the leaves, and of course that gets eaten by animals, which gives them a source of food and so on. Each year the photosynthesizing organisms produce about 170 billion metric tons of extra carbohydrates, and that's about 30 metric tons for every person on the earth. That's what the plants are doing. They use the energy of light to convert carbon dioxide and water into a simple sugar called glucose. How do they do it? It turns out this process is in 2 stages. There's a light-dependent reaction, pretty obviously, and there's a light-independent reaction. The chloroplast traps the light energy, converts it to chemical energy, and then it's contained in 2 types of molecules. And I won't try to pronounce these long names. NADPH we'll call the one, and ATP the other one. And then there's another, once that process generates those 2 chemical sources of energy, then the NADPH provides the hydrogen atoms that help make up the glucose. The ADP provides the energy for all this, and the reactions need to synthesize the glucose. Light energy boosts, what happens, the light energy boosts the electrons in the chlorophyll to boost up in and out of their orbits, and as it does so, that acts like a row of pinballs. One passes that energy to the next, and it all happens in millionths of a second. The light-dependent reaction I'll call photosynthesis, photosystem 1, we'll call it. Those pigments capture the light that is in the frequency of 700 nanometers. That's a particular frequency in the red, and that's why they call that particular kind of chlorophyll P700. And it's called that because it absorbs a very particular frequency of red. And the electrons that are then released or get passed down one to the other until they finally create NADP, how I can do this without getting in all the detail. Basically, the energy is going to be in a form that it can then make the thing thereafter, because it'll pick up a hydrogen ion and make the NADPH, which we'll need in a minute. Meanwhile, the electrons have been depleted doing all this, so they need to be replaced. So there's another photo system, I'll call it photosystem 2, that has a form of chlorophyll that focuses on different frequency of light, 680 nanometers. And as it does the same thing, it passes its extra electrons to the P700, but along the way, it takes the ADP that's around, picks up a phosphor atom, and gets the ADP. This whole process generates 2 things, these 2 chemicals that are needed in the next system. And that's the light-dependent reaction. And it's a whole other system. If we take the water that's there, and the water will break down into ions, hydrogen ions and oxygen ions. The hydrogen of the water will provide the hydrogen for the one up there, the NADPH. The oxygen is going to go off into the atmosphere. It's extra. Now we get to the light-independent reaction, sometimes called the dark cycle. It's named called the Calvin cycle after Melvin Calvin, who first discovered it. But the two chemicals that were thus made get mixed with CO2 and RUDP. They take 6 of the CO2 molecules, 6 of the others. They mix with a number of enzymes, a fairly complex process, but what comes out of it is glucose, C6H12O6, and there's 5 RUDP left over, so that it returns. And as long as there's CO2, this thing will continue to produce sugar. CO2 and water, of course. Water coming from the roots or even from the air, and the CO2, of course, from the air. Now, and that finally leads to one of the simplest sugars, the C6H12O6. Now, the point I want to get to, without getting into all the technology per se, the kind I want to get, first of all, it's a 2-stage process. That could not happen by chance, because either one, incomplete, causes it not to work at all. It's, again, an irreducible complexity concept. But there's something else to understand here. The plants, of course, give off, as a byproduct here, not only the sugar, but the O2, oxygen, right? The animals need the O2 and the sugar. See, all our food stuff originates here. We may eat the animal, but that's because he's eating the vegetable. You with me? The animals give off CO2, which the plants can't survive without. So we have something very interesting here. You have the plants that need the CO2 that give off the oxygen. You have the animals that need the oxygen give off the CO2. You take away either one, they die, ultimately. Now you say if all the animals died, it'd be a long time before the plants did. Yes, but it would eventually, because they won't have the O2. They'll use up, they won't have any of the CO2. There's no CO2 given off by this. You follow me? So it's interesting. You can ask, which came first, the plants or the animals? The plants did because they happen in day 3. The animals aren't coming till the day after tomorrow, okay? All right. But I want to acquaint you with something that's very fundamental and very important. It's something that the unbelieving scientists call the anthropic principle. It's a label. What do they mean by that? It's at least the appearance that the universe was designed for man. Now you'll say, well, that's obvious. Of course it was. No, wait a minute, because the Bible says so. Wait, let's step back a minute. The universe itself bears evidence that it's been tuned specifically for you and me. What do I mean by that? If we try to construct a mathematical model of everything we believe that we know about the universe, we discover there are hundreds of delicate ratios that, if altered in the slightest, make life impossible. Not 2 or 3, hundreds. And some of these are so delicately that 1 part in 100,000 changes, and life doesn't happen. And that's what they call in fact, 10 to the minus 55, that's really small. Paul Davies, who's an internationally known, brilliant writer, atheist, scientist, he even says that it seems as though somebody has fine-tuned nature's number to make the universe. The impression of design is overwhelming. No kidding, Dick Tracy. But the point is, he's not a Christian. But he is acknowledging, maybe reluctantly, he's acknowledging that it sure looks like the universe is, anyone that denies design is being irrational. That's really what, in effect, he's saying. Let's talk about a few of these. There are 4 forces in nature. Gravity, we know what gravity is. Electromagnetic force, there's 2 nuclear forces, what they call the strong one and the weak one. Gravity, of course, we know what that causes an apple to fall to the ground. It keeps our feet on the floor. It also binds together our solar system. We'll talk about that next time. It keeps the Earth and the planets in their orbits, in other words. It prevents the stars from exploding, among other things, and it guides the galaxies in their motion. That's what gravity is all about. The electromagnetic force, that includes light, radio waves, and all those things, it holds the atom together. It determines the structure of the orbits of the electrons, which of course determine molecules. Therefore, it governs the laws of chemistry. It also forms X-rays, radio waves, light, are all forms of electromagnetic force. It can overcome the gravity on the Earth. And it can dominate other forces down to the size of the nucleus of an atom. When you get down to an atom, things change. There's a strong nuclear force that binds the protons, the neutrons together in the nucleus of the atom. There's a balance between the strong force and the electromagnetic forces that limit a nucleus to about 100 protons. You can't get any bigger ones than that. It just turns out it won't happen because of the balance between those two forces. So the ratio of those two forces determine, in effect, the periodic table for us. And the energy released is substantially greater than the electromagnetic. If you can release this energy, it's much bigger than electromagnetic. That's what we call an atomic bomb. It also causes stars to shine, which are essential for life, interestingly enough. The weak nuclear force is the smallest. It governs the atomic instability and radioactivity. It causes disintegration of the heavier nuclei. It can create heat, as the decay of radioactive elements in the Earth's core and so forth, or in a nuclear power plant. And then you have, so let's start talking about some of these ratios. Gravitational coupling. If the gravitational coupling was stronger, stars more massive than our sun by 1.4 times, they would burn too rapidly and too inconstantly to maintain life-supporting conditions on any surrounding planets. If it was any weaker, all stars would have less than 0.8 times the mass of the sun, and there'd be no heavy elements in the universe. Electromagnetic coupling. If it was weaker, the molecules for life would cease to exist. If it was stronger, the molecules for life would cease to exist. It's at an exact point that causes these molecules to be possible. Somebody had to balance it. The strong force coupling, if it was weaker, multi-proton nuclei would not hold together. Hydrogen would be the only element in the universe. If it was slightly stronger, nuclear particles would tend to bond together more frequently and more firmly. Hydrogen would be rare in the universe, and the supply of various life-essential elements heavier than iron would be insufficient. What about the weak force coupling? If it was larger, there'd be no helium, no heavy elements. If it was weaker, there'd be all helium and an overabundance of heavy elements. See, again, it's a delicate balance. The ratio of electron to proton mass. This is a strange one. It happens to be exactly 1 to 1836, that ratio. It's any other ratio, it all falls apart. If it was larger, molecules would not form, and life would be impossible. If it was smaller, molecules would not form, and life would be impossible. It's astonishing to realize how delicately all these things work together. Let's take simple things. The distance from the sun. If we were closer, it'd be too warm to maintain a stable water cycle. If we were further away from the sun, it'd be too cold to have a water cycle. That's what's wrong with so many of these planets. They're not the right distance from the sun. Surface gravity. If it was stronger, the atmosphere would have too much ammonia and methane. If the surface gravity was weaker, the atmosphere would lose too much water. It's right at that balance to make life possible. The thickness of the Earth's crust. If it was thicker, there'd be too much oxygen to be transferred from the atmosphere to the crust. If it was thinner, volcanic tectonic activity would be too great. Earth rotation period. If it was longer, the diurnal, the daily temperature differences would be too great. And if it was shorter, the wind velocities would be too extreme. Axial tilt. You notice we're tilted on the axis. If it was either greater or if it was less, the surface temperature would be too great in either direction, strangely enough. And albedo, that's the reflectivity of the Earth. If it was greater, a runaway ice age would develop. And if it was less, a runaway greenhouse effect. The reflectivity of the Earth is just right to maintain that range, which allows life to exist. The Earth's magnetic field, if it was stronger, electromagnetic storms would be too severe. If it was weaker, there would be inadequate protection from the cosmic rays and stellar radiation. And CO2 and water vapor, we talked about CO2 and water vapor. If there was greater levels, the runaway greenhouse effect would develop, and if it was less, the greenhouse effect would be too insufficient. It's just the right balance. Ozone level. I love this one because the ecologists keep telling us, boy, if there's 0.1% change in the ozone layer, it brings cosmic doom. The next time someone points that out to you, turn it around the other way. Who balanced it? To the extent that it's delicate, proves it couldn't be there by chance. If the ozone layer was greater, the surface temperature would be too low, and if the ozone level was less, the surface temperature would be too high. There'd be too much UV, ultraviolet radiation at the surface. And on it goes. All these things, I've just given you a few, there are literally hundreds of these kinds of relationships. Every one of them has to be balanced just right. And there are some scientists that say, gee, if all that's true, then there's certain energy levels of certain atoms we haven't discovered yet, and they looked and they were right. They use this principle to actually make new discoveries. That's a form of validation of science. Let's talk about extraterrestrial communication. There's Project Cosmos. They've all been looking for extraterrestrial life. You know, what fascinates me about these scientists that look, what's their evidence that there is extraterrestrial life? They'll get information. If there's any information, see, there's two things they don't want. They want random noise, there's no information. Or if there's periodic information, that's like a sine wave, well, that could be from a natural cause, like a pendulum or something. But what they need is something that's not random and not periodic, something in between. That's why prime numbers are always used as an example and so forth in the stories. The Communication for Extraterrestrial Intelligence had a meeting at the National Academy of Science in Boca Raton, Russia. 84 of the world's top scientists met, and they were trying to determine what's the probability of life in the universe. And they used what they call the Green Bank formula. If you take the number of civilizations they expect in the galaxy, would be the product of these numbers: the rate of star formation, how fast the stars form, what fraction of those have planets, how many of those planets have life-capable ecology, how many of those actually have life then, and what fraction of the life-intelligent beings then develop out of that and get to a level of communication, and what's the mean lifetime of technological. If you take that product, you'd come up. It turns out what it's useful, the reason this form is useful, it allows you to focus on the various stages that you need to look at. Because the kinds of people that are experts on the rate of star formation aren't the kind of people that would have these other skills. So they shared all these things, and I'll give you the short version of this. As they analyze this, they don't realize it, I don't think, because I read the papers. You can buy them, they're published, translated and published. They in effect are, as they express their frustrations here, they put the nails in the coffin of life happening by accident. They acknowledge reluctantly that life is unique and a miracle. Because you go through all these estimates, even making very gracious estimates, you still come out with next to zero at the end. Very pessimistic conference from the point of view of extraterrestrial intelligence. Very fascinating papers to read. Much of what we learn, the progress of science, is what their speculations are in each one of these sectors. And so anyway, for what it's worth. A couple last things I want to clean up on this thing. The secrets of the Torah are revealed by the skipping of letters. Remember we looked at that in our introductory thing from Rabbi Cordovero in the 16th century. I want to show you, we looked at some equidistant letter sequences before. Let me show you one that is kind of fun. You remember an equidistant letter sequence is when you have a message that contained in it is a secret message by taking every nth letter, every fourth letter, whatever. In this little example, we take every fourth letter, and it says, it's just a little message. It says, read the code. In other words, here you have a message inside a message, so to speak. Well, with computers, we're here in Genesis. We're talking about trees. In Genesis chapter 1, verse 29, we haven't got there yet, but again, it'll speak about the seed-bearing trees. And when you get to Genesis chapter 2, verse 9, out of the ground the Lord God made grow every tree that is pleasant to the sight, and so forth and so on. Are we together? What's fascinating, if you look at the Hebrew text of that passage, you find 25 trees that are mentioned in the Bible, encrypted in those verses. At spaces of 2, 3, 4, 5, 6, some as high as 18, some a little larger. But it's fascinating that within those texts you have these trees in the Hebrew tucked away in code in those passages that deal with that. Is that significant? People argue. Some say, no, it's just an accident. Other people say, wow, this is wild. And they go from here to all kinds of crazy conjectures. I'm not going to go there. But I did want to call that to your attention that it does appear that there's far more design in the text itself than we have any hidden below the first meaning of the text. And something else I want to share with you, and then we'll wrap it up. On the third day, in John chapter 2, we all know the wedding at Cana. How many knew about the wedding at Cana? Right? Okay. Chapter 2 opens, on the third day there was a marriage in Cana of Galilee, and the mother of Jesus was there. And both Jesus was called and his disciples to the marriage, and you all know the story, how they had no wine, and Jesus turned the water into wine. You won't really understand that story until you understand what water he used. It wasn't plain water, it was the water of purification. And the only people that knew it was a miracle was his insiders. There's a lot to that more, but all I want to get here is one thing. What's this third day business? We all read that in Genesis, and the third day was a marriage. Third day from what? There's no preceding condition here. John 1 was before, that was the introductory chapter. And the third day, there was a marriage. What on earth is that? You know that most Christians don't know what that is. So you're going to be an exception. You're going to know. Because this third day issue. We've just been studying Genesis chapter 1, the third day of creation. Now, before we got to the third day, we had these other days here, right? You'll notice in the beginning God created the heaven and the earth was without form and so forth. God said there was light. And then it says, and God saw the light that it was good, and God divided the light from the darkness. So in the first day, what God did, he saw it was good. Did you notice that? That's on Sunday. The next day, second day, he did the firmament and the waters and this and that. Where does he say it was good? See, Monday is very unique because he doesn't declare the work of Monday good. Every other day, other than this one, he did this and that and the other thing and saw that it was good, right? We can put our tongue in our cheek and say he had a bad Monday. So you feel unique when Monday's a tough day, right? When you get to Tuesday, which is the third day, he blesses it twice. Let the waters in the heaven be gathered together and so forth, and let the dry land, earth, gathering the waters you call seas. And God saw that it was good. Notice that? Then he brought forth the grass and the herb yielding seed and so forth, and it was so. And you get down there to verse 12, and God saw that it was good. So Tuesday, the rabbis call the day of double blessing. He blessed Sunday. He didn't bless what happened on Monday. He blessed Tuesdays twice. Wednesday, Thursday, and Friday will have their blessings, okay? So Tuesday is the day of double blessing in the Jewish vernacular. And for that reason, Jewish weddings are always on Tuesdays. Do you know that? Isn't that neat? Yeah. So that, and of course, some prophecy extremists say that obviously the rapture also will be on a Tuesday. Now, what's the logic? No logic, it's just a conjecture. But so the Tuesday is the day of double blessing. And so you're probably wondering, why do we have our Bible studies on Tuesday? For lots of other reasons too, but let's see, it was good. But it's the day of double blessing. And so I hope Tuesday will be for you a day of double blessing. Just to see where we're going, we've had the introduction to Torah. We took day one. The second day, the Big Bang models and the quantum physics stuff. Today we talked about the origin of life and molecular chemistry in a modest way. Next time, we're going to talk about the nebular hypothesis. Where did the planets come from? And everything you've been taught is wrong, even from a scientific point of view. They did not come out of the sun. They couldn't possibly have. I'll explain why. And we'll talk about the signs in the heavens. Did you know the stars are positioned there to carry a message? The heavens declare the glory of God. Oh, really? How? Through telescopes? Yes, but there's another way that'll surprise you. And we're also going to discover what God calls the appointed times. They often say a Jew's catechism is his calendar. And we're going to see how that calendar ties to the fourth day. And then, of course, we'll go to fish and fowl, and we'll really nail the fallacy of evolution and all that foolishness. And we'll talk about animals and man in day 6. And the DNA, we'll get into that a little bit there. And the architecture of man. And then we'll come to the seventh day. And some of the surprises that are on the seventh day. So there, anything. Let's stand for a closing word of prayer.